Okay, so in this lesson we're looking at section 5.3. So this is section 5.3, methods that return. So we're going to look at a new kind of method. First of all, we're just going to write a method that will figure out the max of two integers and then print it out. So we're going to look at two different examples here and the subtle differences in each. So I'm going to take in two integers, let's say int a and int b. Now I'm going to check which one is larger. So if a is greater than b, I'm going to write system.out.println a. Else, what should I print now? System.out.println b. Now another subtle thing is I could also do this. So let's play our favorite game show. Will it compile? Does this compile? Okay, so in the main method we just create a scanner and we ask the user to enter two inputs for A and B. So it should compile, and it does. Okay, let's see that again. It does compile. But if we run it, actually, right now it's not going to do anything because we didn't even call the method. So let's say 3 and 8, and it does nothing. So let's call the method. How do I call that method? The name. So it's called max. So I'll just go max a comma b. Or I could even go b comma a just to throw you off. Now, interestingly enough, a and b, even though they're the same variables names, these are different variables. So a and b are considered to be local variables inside these curly brackets. These curly brackets always define the scope of a variable. So a and b are valid within this scope. This is a brand new a and b, which is totally different than these two a's and b's. So this a, it's just the order. So this b actually gets mapped into a. This a gets mapped into b because the order is what matters. I could call these x and y. I could also call them a and b and have the same names, but they're different variables. Now the mapping is what matters. So x gets mapped into a because it's first. Y gets mapped into b. So now let's try this. And it says enter two ints, and I'll say 5 and 9, and 9 will print out because 9 is the larger of the two. Does that make sense? Now, what if I change this because I wanted to do a for loop? Let's say I wanted to do a for loop to print out all the numbers from the smaller one. So loop, let's say print out all the numbers from the smaller to the larger. Right? So I wanted to have another method for min. Maybe I wanted to have another method for min. Because I could do this in the main method, but it's nice to have these methods here like this. So let's say min, not mind. And this time we change the sign. So if a is less than b, return a. Otherwise, return b. So if I want to print out all the numbers from the smaller one to the larger one, so I can say for, how do I do that? You know, I'm kind of stuck now because if I call min, so I can call max xy. So this is not, I could store these in variables, and min x and y, but all that does is print them out. Right? So if I say 5 and 25, so 25 is the max and 5 is the min. I could have put, system.out.println lines here to print those, or to print those better. The min is, the max is. But I want to go from the min to the max. So the problem here is that these methods are very limiting. They're limiting because they're not giving any answer back. And if they're not giving any answer back, all it does is it prints out the values. That's no good. So it's not really helpful to just print out the values. So instead of doing this, we are going to return the value. So rather than just printing it, we're going to return it. So we're going to take that void and turn it into an int because we do want to return an int. The return type doesn't have to match the parameters at all. Okay, it can be something totally different, just depending on the data type you're trying to return. So in this case, we're returning A. So we'll write a return statement, but we'll put something there. Return B. Same thing here. Return A. And return B. Okay, so now these things return things. So because they return things, I can actually make them into variables here. I could say int smaller equals, sorry, that would be larger, equals the max of xy, and int smaller equals the min of x and y. Now it doesn't print them here. What it does, if you follow the flow, is it sends in the two values, x and y. The right-hand side is still of the equal sign is always done first, just like any assignment that you've done before, any assignment statements. So the x and the y travel in to here and here. Then, it figures out which one is the smaller one in this case, and it returns it. And when it returns it, it replaces this with the return value. So that gets replaced. And that's why now, if it's a void method, we can't do this on the left-hand side because it's not returning anything. But now because it returns something, we can store that in the variable on the left-hand side and save that. And now we can use our for loop. Because maybe we didn't want to print it out. We didn't want to print out the max and the min, but we wanted to use it. So now we can say for int I equals smaller, I is less than or equal to larger, I plus plus. And now we can go system.out.println I. And what that will do is it'll print out all the values. So let's try to compile that. Oh, I got an error. Oh, so this is void. So if it's void, you can't return anything. So I have to change that to int. So that's the return type. Works directly with that. Okay, now let's run it. Enter two ints, -4 and 16, for example. So it's going to go from -4, count all the way up to 16. Run that program again. Let's say 3 and 6. It'll go 3, 4, 5, 6. So we're using the return values in the main method here. You could have put these directly without even making other variables. You could have put these variables directly in here. The problem with doing that, though, is it does create more steps. So let's take a look at this in the Java visualizer just for interest's sake. It's always interesting to look at how things work behind the scenes. So let's erase this. Okay, so now we've got these two methods. So notice we're calling min and max here. So visualize execution. Oh, what do we do? Crazy methods. Public class, crazy methods. Oh, the scanner. It doesn't like the scanner. So what we're going to do is we're just going to hard code the values in the Java visualizer. That's what we do, right? So we're just going to say 5, well, let's say 3 and 6. 3 and 6. So now let's see how many steps we have here in this algorithm, how many steps the processor has to do. So we hard-coded the values in rather than getting them from the input. We start there. We say get two numbers, but we just hard-coded the values in 3 and 6. Now we go larger. So we go up to larger, and we send in 3 and 6. So now A and B has the values of 3 and 6. You can see them here in your frames. So then, of course, it does return B because 6 is bigger than 3. So it returns B. And where does it return it? So it says its return value, which is matching this, is 6. And it returns it back to this line. And it puts it in this variable on the left-hand side called larger. So now it's sitting in there in larger. So larger has 6 now in the main method. Then we go to smaller. We're trying to figure that part out. The min method, we send in A and B as well. This time A is less than B, so it returns A. And so its return value is 3. We go down here, and it replaces this with 3 and then puts it in the box or the variable called smaller. So now smaller is 3. Now, it then goes to the for loop, and it goes from smaller to larger. So I gets the value of 3, which is smaller. Okay, and then is smaller less than or equal to larger? Yes, it is. So then it goes through, and it starts printing those values out until it reaches the larger, which is 6. And there we have it, 3, 4, 5, 6. Now, how many steps is this? Can anybody see? Let's go back to first. 31, right? Now, what if I just took this? I could even take this, instead of making these variables, and put them in here. Do you think our steps change, or they stay the same? Our number of steps, do they change, or do they stay the same? So now I got rid of smaller and larger, and I put these values directly in to that for loop there, min and max, right? What happens? Well, how many steps did we have before? Who remembers how many steps we had before? 31. Now we have 49. What changed? Why is it different now? So a subtle change like that can save you lots of steps, which on something like the Waterloo contest where they measure you by time or efficiency, a small thing like that can make a big difference. So you can see that we've gone up almost 20 steps in our step count here. If the numbers were bigger, we would have gone up even more steps. So we just hard-coded 3 and 6. If we change these numbers, obviously the step count would be different. But a subtle difference here in the way we coded this, because now, okay, yes, this one is still being called only once, but think about the for loop. How many times does this get called now? It's got to check your condition every single time through the for loop. And every single time through that loop, it's going to be, so it's going to call min once. Then it's got to check if it's less than the max, but it's got to call that max method every single time through that for loop. Instead of calling it once and just saving that value in a variable. Everybody get that difference? So that's why the step count went up. So it's always interesting to try these things and experiment on your own as well when you're coding. Like, does it make a difference? Does it not make a difference? Okay, so next. Any questions so far? Everybody understand the methods that return? We can have different return types as well. We can return doubles and strings. We can even return arrays. Okay, so if we wanted to return an integer array, we could do something like that. But obviously then A or B should be an array. Okay, so that should have square brackets around it. Now, what is the benefit of this? Let's copy and paste this method. Actually, before I get to that, what if I did this? Interesting question. What if I did A less than or equal to B, return B? Okay, so we want to find out if which one is the max. That's what this method's doing. So if A is bigger than B, return A. If it's less than or equal to B, return B. All right, so is this the same thing? Is this the same code that I had before? Same code? Let's play our favorite game show. Will it compile? Does this compile? Put your hands if you say it compiles. It does compile. Why wouldn't it? Put your hand if you say it doesn't compile. Then put your hand up if it does compile then. Compiles? Okay, we got one hand. That's just one. Put your hand if you say it doesn't compile. Anybody say it doesn't compile? Does not compile? Put your hand if you're not sure. Nathan, what do you think? It compiles? All right. Put your hand up if you didn't put your hand up. Wow, there's people not putting their hands up. All right. So, drum roll. It does not compile. It says you're missing a return statement. But there's two return statements, in fact. Why does it not compile? Sorry? It's an else if, right? So what if these are both false? Now, mathematically speaking, is it possible for them both to be false in this case? No, it's impossible. We've taken care of the number line completely. I mean, if we've forgotten that, then yes, it would be impossible for them to be false if they were equal. For them both to be false because they would be equal. But in this case, we didn't forget the equal sign, and it's impossible mathematically for both of them to be false. It's impossible. But does Java know that? The Java compiler doesn't know the values, and it does not evaluate conditions at compile time. So this is an important point. It does not evaluate conditions at compile time. It evaluates the conditions when the program is running. So at compile time, it just sees I have an if, which could be false, and I have an else if, which could be false. Two things that could be false, and therefore, if they're both false, I have no return statements, but our method says it should return. Right? You paying attention? You just made it to the YouTube video. In that case, that's why the else works, because if the if is false, the else has to be true. So you have to make sure that in every method that you're returning something, that you do have a return statement through every branch of that method. Questions over there? No? Good. Questions about that? Make sense? Okay, so I just wanted to mention that. Now, one more thing about methods that return, because we're still on that section 5.3, another subtle thing. So what if I did, let's do this method again. Just going to copy and paste it. Let's do this method again, but this time we'll make it void. We'll make it like the old way, system.out.println. So we saw that this one is not as flexible, right, as the previous one. And so does everybody see why it's not as good? Well, first of all, we'd have to call this one something different because the parameter list is the same. So let's just call this max print because it's printing out the larger of the two. This one's returning the larger of the two. So I want you to fully understand why. It depends on what you want. Both methods work. They both compile, but they do different things. This one finds the answer and sends it back. This one finds the answer and prints it out. Now, you might think printing it out is useful, but it's very rarely useful that you want the answer to be printed out. Sometimes you want to use it in another part of the question, like we have used it here. In our for loop, the larger and the smaller values. Printing it out was useless in this case. Okay, so we didn't print out the larger and smaller values at all, but we used it for some other part of the problem. So think of this method. Sometimes my mom calls me and she wants help with something. She's got to do something with the taxes or the CRA or whatever, the government. And she calls me on the phone. When she calls me on the phone, I'm like the method. And she says, Chris, because my mom calls me Chris. Sometimes she calls me Christopher. But my mom calls me Chris, and she goes, can you print this thing out and mail it for me? Print out this document. I don't have a printer. And mail it to the government for me. That's kind of like this method. So she gives me the information I need, sends me the document, whatever I need to do it. I do all the calculations I need to calculate. I print it out. I mail it to the government. She's done. When I hang up the phone, she's done. I do everything. That's kind of like this method. Another scenario would be sometimes when my mom says, here's all the information. Can you print it out, calculate everything, and then I'll wait on the phone and you email the form back to me. That way I have a copy of it. If I need to send it to the government or mail it, I'll do that part. So you print it out, do all the calculations, send it back to me. That's kind of like this one. So now we can send the information back to her, and she has it. If she needs to print it out or send it to the government or whatever, she can do that. But she has a copy herself. So what we've done here is we've made this method far more modular and useful by doing this. This one is the more modular and more useful method because it can be reused in many, many scenarios. Sending the answer back is better than just printing out the answer in most cases. Okay, it really depends on what you need, but usually sending the answer back is much more flexible. And again, you can see in this example how we use it in other parts of our problem. So we solve a small problem and then use it to do something else later. And you can see that that's nicer than I don't have to, put all of this code in here. Okay, you can just say I'm trying to find the max and the min. So we're calling these methods. You've also seen methods that return. And you've used them all of last year when you did things like math dot, let's say seal 31.0005, which gives us back 32. So this is what it's returning, right? So we could store that in a double. We could say double answer equals math dot round. Let's say math dot square roots 25. And remember how I was saying doubles, and we've done Kahoots on this. Doubles, math dot square root always return a double. So if you tried to put that into an int, you get a syntax error because, you get two syntax errors there. Let's call it ANS1. We already declared that variable. But it says incompatible types because math dot square root returns a double, whereas this returns, this is an int, so we can't put a double into an int. So how do we know what methods return? We look at these things are called the method headers. And we see what the return type is. Right? We see what the return type is. So you can open up the Java. You just Google Java API, which is the programming. It's the application. What does API stand for? Application Programming Interface. Good. So I click into this frame here. I can go Control F and look up math. There's math over there. Now it's really small. Let me make this bigger. Okay, now let's say we wanted to go to square roots. It's in alphabetical order. All the methods are in alphabetical order. So we can come here. So this is the textbook for programmers. They don't actually have textbooks. They use the API, Application Programming Interface, to look things up. Sometimes the API is built into the IDE. That's lots of acronyms there for you. API, the Application Programming Interface, which has all this information, is built into your integrated development environment things like JGrasp, but it's not built into JGrasp, but it's built into the other ones like NetBeans and so on. That's why a lot of students don't like JGrasp, because the other IDEs, they make it a lot easier. You just start typing SQ and it's like, oh, it reminds you what the documentation is because it's built right in. But I kind of like the idea of you guys starting this way and then making it easier later. You start with the hard stuff and then you make it easier later because you know then where it comes from. It's like, in advanced functions, you do things from first principles, right? Have you done f of x plus h minus f of x all over the limit as h approaches 0? Have you done that yet? You haven't done that yet? Okay, you'll do that soon. Anyway, you'll later learn that there was much shorter and faster ways to do that math, and you'll be upset. But you had to do it from first principles to understand where it came from. This gives you the whole method header up here, doesn't it? Public, static, double. There's your return type, square root. So you know that it's returning a double. So don't try to put this into an int in SQRT, right? Which one was the funny one? Remember there was one funny math one? There was a funny one. Not funny, haha. Funny like weird. Strange. There was a funny math method that sometimes it returned an int and sometimes it returned a double. Nobody remembers? Okay, we'll talk about that one tomorrow. So we've talked enough today about methods that return. Any questions about methods that return? So you've used them many times already. You've used methods that return. Oh, one quick thing. Why the math? Because it's not in this class. So math is the name of the class in which that method is. So again, code reuse. We can call methods now from other classes. If it's in the same class, we do not have to do that. So I can just write max and min. But let's say I wanted to call this method now from another class. Then I could put the class name, methods that return, which is the name of the class, dot min, and I can call this method from another class. You can have multiple classes in one file, yes. So that's why over here you were writing math.this, math.that. There were all of these methods that belonged in this math class. Okay, any questions? Okay, I'm going to stop recording.